All right, well, the Florida weather is starting to come around. It's really not that bad. I mean, it's still a little warm, but I'm not drenched in sweat just being in the shop like I normally would, so that's nice. All right, so the plan for today, let me turn this off so it's not so loud, is to build a new welding cart. So I built this welding cart about, I don't know, probably a year ago now, somewhere in that range. When I built it, my idea was to save floor space. So I had this AHP, which is a dedicated TIG, and then that Everlast, which is a multi-process, does MIG, TIG, and stick. So I wanted to put them both on the same cart so that, you know, I didn't have two separate carts taking up floor space. When I built it, I wanted this to kind of be free floating, so I used really thick wall tubing, which made the cart pretty heavy. And with both welders on it, I mean, this thing is incredibly unwieldy. It is just very, very heavy. It's hard to push around. It's hard to steer. And on top of that, with the TIG, you usually have a pedal. So I like to run the cable for the pedal back behind the workbench and out so it's nice and tucked away and doesn't get in the way. But if you keep having to move the cart out to go weld something on the car, you're constantly like digging the pedal out, pulling the wire out, stacking all that on top of a cart, all this stuff for two welders, and then trying to wrangle this thing over to where you need it to go. And that just made me never want to have to move this thing. Like I would avoid tack welding stuff or welding stuff on the car at all costs, so I didn't have to like fish this thing out of there. So that's one reason. The other reason is I upgraded to a water cooler, water-cooled torch setup. So this is the torch I've been using. This is a number 17. This is probably the most common torch out there. It's got a flex head, super handy. I could never own a torch after having one with a flex head without one. But it's an air-cooled torch. It's rated to 150 amps. And anything really over 100 amps, if you're doing decently long runs, it starts to get really hot, especially up in this area. And I like to hold the torch really far up because any bit of movement is way more finite. So by upgrading to the water cooler, I was able to get this torch. So this is a number 20. This one's kind of odd because it's called a flex lock, so I can twist this head 360 degrees so you can get into tight spots and weird angles and stuff. But basically this has water running through it all the time. So when you're welding at the same amperes that this thing would be burning your hand off, this thing is still room temperature, which is amazing. And this torch is smaller, all while being able to handle 250 amps instead of 150. So this is something I wanted to do for a while. I'm really glad I did it. I've been doing some welding with this thing and I absolutely love it. It is amazing. But naturally the water cooler had to go somewhere, so I put it on this cart. I'm gonna make a few revisions to this cart. You know, like I need to make a setup to hang the leads. I need to make some other stuff, and I wanna make a cabinet for TIG cups and tungsten and all that stuff to keep that nice and organized. But one thing I did notice is I thought the cart was just super heavy from being overbuilt, but with this on here, which is much lighter than the other welder, this thing is cake to move around. It is not heavy or unwieldy at all. So basically that's my setup for this cart. We've got the AHP, dedicated TIG welder, we've got our water cooler, and we're gonna go through and modify this and make it kind of perfect for TIG welding, TIG rod holder, all of that stuff. But that cart works for now. Like it totally works just fine as it is. So I'm not worried about modifying that right this second. What's more important is getting this thing back on a cart and my plasma cutter. Basically my goal is to make these two my kind of mobile welding rig. So we're gonna have it set up to do all sorts of different stuff since it is a multi-process welder, and we got the plasma cutter, and basically that's gonna be my setup to roll around the shop and go wherever I need to go. And then this is gonna be kind of like my bench TIG with the water cooler and all that. I do have 25-foot leads on this in case I need to weld stuff across the shop. I probably won't need to use it, but I figured it's better to have it and not need it than need it and not have it. So we've got that. I went and got a bunch of material the other day, not just for this project, but just to kind of have a bunch of material for spare project. That way I don't have to drive an hour to the metal supply place every time I need to do a little project. So we've got what we need to build the cart. Now we just need to come up with a game plan of how we want to build it. I have an idea in my head, but I need to try to put it on paper and start coming up with some dimensions. The material that I have is 2 inches wide and 1 inch thick. So I plan to, on the bottom, have it flat where the 2 inches is this way, and then on the top, have it up where the 2 inches is this way. That way, basically the top shelf, I can recess further down so stuff doesn't slide out of it. And the bottom shelf, basically where the diamond plate's gonna go in the center, be barely recessed so it's easy to get the welder, the plasma cutter in and out. So that's my rough dimensions for the bottom. I'm gonna kind of draw up what I plan to do here. All right, so here's what we got. Welder, plasma cutter. This area is open, but it's going to have to be to open the door to get to the MIG spool, the wire spool. So we're gonna leave that area open with enough room here. That room works out perfectly for the other half, which is our gas bottle. So we'll have, argon C25. Instead of putting them behind the cart and leaving this dead space, I wanted to integrate them into the frame so they're inside of it. One bottle here, one bottle here. Still have room to get to the air port on the back of the plasma cutter. And then I have another trick up my sleeve with the plasma cutter. A little idea I want to do. I don't know how well I'm going to be able to do it, but basically, since this welder is a decent bit taller, especially with the handle on it, my plan is to suspend the plasma cutter like this, and then that way, you know, build a frame for it. And then that way I have storage underneath it. Because if it's like this, I can't really stack stuff on top of it, it'll just fall off. But if I have it up in the air, then I can easily store stuff underneath it. So that's kind of my game plan. I'm gonna just start off trying to build out the frame. I think that's gonna be the best bet, but it is gonna be square, which is what I wanted. I'm basically having both of these on the bottom instead of double decker like the other cart. I'll be able to have this whole area open. So when I'm working on a car or something and I'm welding stuff, I can set the pieces of exhaust there, I can set rod there, whatever I need. It's funny, when I built my first cart, I didn't have this welding top. I had just, I don't know, maybe 2 foot by 8 foot table. So having this to build this cart is gonna be so much better. I should be able to fit the whole thing on here. So I've got these pieces, which are kind of the leftover like 4-ish foot pieces. So if I cut my 31 inches out of these, I'm gonna have a really long but not usable for what I'm doing section left over, which I don't want that. You know, that'd be a waste of material. Whereas this piece, I can cut 3 out of it and end up with only like 4 inches left over, or 3 inches. So just, you know, just basically try to plan out your cuts based on the length of the pieces you have. Lay it out on a few and just try to pick the one with the least drop. They had a bunch of this thick wall stuff, like 8th wall, and I don't think it's that thick, somewhere around there. They also had this 11 gauge stuff, just a lot thinner. So I want to use this for basically the top rail and then use the thick stuff for the bottom and the supports, just to try to save some weight where I don't need it, more or less. Okay, so we need to start by cutting a 45 on the end, because we're gonna need 45s everywhere. Our long length on the 45 is gonna be 31 inches. So we'll cut a 45 here, measure 31, cut our next 45, and so on and so forth. Okay, well, I kind of forgot about the fact that these pieces are 8 feet long, and there's not really any good way for me to get them in the saw unless I hang them over that way, which makes supporting them even more difficult. So I'm gonna do it in the chop saw, I think. I think it's really my only option. It has been a while since I've used this thing. Forget how much cutting with the chop saw sucks. See how close we were able to make these two. It's very tricky with the chop saw to get a perfect cut. That's pretty darn close. Maybe like less than a 16th off. Really just in the center, because this was a rough first cut. Wow, all right, pretty much dead on with those two. 2 more to go. So we're gonna basically rely on our inside measurement for this one. And I'll go ahead and mark my outside as well. I put it in the saw. Get it lined up by eye first. Bring the saw down, measure to the inside of it. Kind of tricky to do with one hand. All right, and see, we're a little under 27, so we need to bump it a little longer. Not much. Now we got our 27 to the inside of the blade. Since the blade doesn't go all the way through, I had to come back, hold it by hand. All right, let's hope we got that right. It got a little sketchy on me because the clamp wasn't holding it good. Yeah, it's right. They're like 27 and a 16th, but that's to the lip. If we go edge to edge, we should get 27. Yeah, right on 27. Sweet. For something like this, I'm more concerned about everything lining up with each other than being the exact dimensions they're supposed to be. Let's see, I need to get an idea of how tall my support legs are gonna need to be. 19 basically to the top of the handle. 21 will give us 2 inches to squeeze it in there. All right, so we've got our 4 pieces cut. These are gonna compose the bottom frame. So now we just need to throw them in the vise and just clean up all the edges with a flap wheel. The grinder is so out of balance, it gives me some major arm pump. All right, moment of truth. How does everything line up? All right, I gotta shave some off of this one. This one, for whatever reason, came out about an 1/8 inch bigger than the rest, and it's gonna ruin the fit up if I try to run it. So we're gonna try to cut that a little shorter. So the pitfall to using something like a chop saw is you end up with bad fitment. So I've got this fitting pretty good. This side fits okay. I think that's probably our biggest gap. You know, it's okay down here. We get a little bit of a gap, and then same thing over here. We can get it pretty tight, but it's, you know, I have to flip the pieces around and mess with it. I'm definitely gonna go grab, after I tack this frame up, grab a new disc. Because the problem is, like I said, I can't cut all the way through it. Basically, it stops shortly before it makes the cut fully. So then I gotta try to hold it in the right spot and cut the rest of the way through. And that's not helping my case any. So for now though, we're gonna work with what we got. So we're gonna just go around and tack it up and fit it up. All right, well, aside from that corner right there, all our gaps are pretty tight. So I can't complain about that. Like I said though, definitely getting another wheel. Gonna go do that before I cut the rest of that stuff. Cause I remember I had this same problem when I built that welding cart. The first half of it, nothing fit right because I was doing the same thing. I went and bought a new wheel and then was able to cut all the way through the pieces. Night and day difference. We do the best with what we got, right? All right, I got the bottom frame completely welded out, welded all the way around. So now I think the best plan of action would be to just start working up and doing, you know, the uprights and then build the top frame and then weld that all together. All right, I got all the uprights cut. I went with 20 inches. I was gonna do 21 originally, but I had that stick over there and it was just over 60. So I wouldn't have been able to do 21. And the more I thought about it, 20 still leaves almost an inch above the handle, and I want to keep this thing as tight and compact as possible. So I decided to go with 20. I have extra material, but no reason to dig into an 8-foot stick when I don't have to. So these we got cut real precise. The first one came out a little short, able to cut the rest of them at exactly that. Pretty precise. So I got to clean these up, and I'm gonna have to grind these welds down on the corners here to get these to sit flush, and then start squaring them up and tacking them. You basically got to kind of set it up with a little bit of out of square and then weld the other side so it pulls back straight, and then hope that it pulls back a little too much so when you weld the other side and then it like ends up straight. To get it like perfectly square, that is. Difficulty is the next set, the top row is gonna be like this. So the channel going around is gonna be like that instead of like this. So this, I have a lot of leeway. If it's off a little bit, I can fudge it and make it work, whereas this needs to be pretty accurate for it to work. All right, so now we're on to our thinner material. All right, so I went and got a new disc. You can see why we're not getting a clean cut all the way through and it's stopping. I thought it would work on the material because now we're cutting it this way at 45, but it still wouldn't go all the way through. So with this new disc, we should be able to do it in one shot, which should make for a lot better fit up. Alright, we got our top rails done. They came out pretty close to even. There's probably a 16th inch variance between the biggest and the smallest, which isn't that bad considering the methods we're using. Because the chop saw, the gantry, if you want to call it that, jiggles a good bit, so it's real easy to get off. But anyway, I'm gonna clean these up as per usual, and then we'll start squaring this up, tacking it together. All right, we've got these cleaned up, ground down, ready to go. Let's hope they square out pretty well and we can get nice tight gaps this time. The fit up this time is a lot better. Alright, I need to go ahead and weld out the bottom so that we can tack it onto the main frame and then weld the rest of it out once it's tacked so we don't pull it too much out of square. I'll get a couple tacks on the bottom and then test fit. Let's do that. Good. Setup's pretty freaking good, man. I gotta say, it is pretty solid. I'm gonna weld the bottoms because I won't be able to get to those, and then I'm gonna go ahead and tack it on. right, so we got this thing fit up pretty good. It sticks out just like maybe an 1/8 of an inch, 1/16 of an inch. Other than that, they're all like exactly where I want them to be. Since we're gonna be standing up to do a lot of this, I went ahead and threw this torch switch on. So we're gonna use this at least at a minimum to get our tacks done. The only problem is it's not 25 feet like my lead, so we gotta kind of leave it out of the housing. I might eventually, I should just get another torch switch that's a 25-foot lead, so I can kind of leave it in here and just slide it out of the way when I'm not using it. But anyway, let's start tacking. All right, got the frame completely tacked up, nice and solid. Man, the torch switch is so handy for stuff like this. I'm probably just gonna weld this stuff on pulse with the switch so I don't have to try to get my leg under here while leaning over here. I mean, I guess I could weld this bottom stuff with the pedal, but top stuff, not so much. All right, I got the bottom completely welded out. Welds came out pretty decent, especially these inside corner joints. They always come out pretty decent. They're real easy. So all of that is fully welded up. Now I need to work on all the top stuff. So I've got a lot to weld up here because I got to weld the frame to here and weld the frame up. So I'll probably weld the frame up first and then weld the bars. So let's get back to it. Switch back from the foot pedal back to the old torch switch for this. I'm gonna try to weld all of this out with the torch switch. Not sure how it's gonna work. I've really only done minimal stuff with the torch switch, but we'll try it. It'll be a lot easier than trying to stand up here and rock the pedal while standing up, so. All right, got the frame completely welded out all the way around. Came out nice. There's a couple spots that are meh, like these joints right here. But other than that, it was pretty easy to weld, just a lot of tossing and turning to get to all the different spots. But using the torch switch, man, super, super, super handy. Being able to use that instead of trying to get the foot pedal in the right spot and lean all the way over here. Worked out really, really well. So really glad I started using that. So next step is gonna be to build the floors. So I'll show you guys what we got for that. We got this 3/4 inch square tube. I think I got 20 feet of it. I hope that's enough. So my plan is to use this as the floor, obviously. The difficulty is I got a 4x4 foot thing of diamond plate to lay over this as like the floor. And I don't think that's gonna be big enough. So my thought is have this welder kind of sit down and basically have these go against the body of the welder and the feet hang down to get the welder as low as possible. And then just diamond plate this side here and the top. I don't know, I'll have to look at it. Getting ahead of myself. So we're gonna have to get these really precise. If it's a 1/16 inch too big, it's not gonna fit. If it's a 1/16 of an inch too small, it's gonna suck to weld. So we want them to just barely squeeze in there. So I learned this lesson the last time. Check your dimension at the spots you plan on putting the bars, because likely it's not the same all the way end to end. So we were real close, but yeah, so we got 26, 13, 16ths. And then up here we got 26 and 7/8, so it grew a 1/16 of an inch. right, that's a pretty snug fit. It's a little looser than I would like, but it works. Let's probably do 2, 3, 4, 3 more. All right, got all our pieces cut for the bottom. I think I'm gonna go ahead and tack all these in. Head and ground the corners down just to give them kind of a nice finished look. This is enough to make one of the U things to hold the deal up. And then basically if I do 2 across the top, that should still leave me enough to do the other part. And then we'll use flat bar in the corners and maybe like in the middle for support. And that should be enough. The bottom obviously needed more support because it's gonna have the welder on it. You know, it's gonna have the most weight. The top is just for setting grinders and tools and parts and stuff while I'm working. So anyway, I guess let me go ahead and cut these 2 out. All right, I got these 2 bars tacked in here. It was a little bit tricky, man, I'll tell you that much. So I gotta weld all that out. I gotta do the flat bar. We still definitely got work to do, but it is getting late. It has been a long couple days putting this thing together. So I'm gonna go ahead and call it for now. We'll pick this back up for a part 2 and we'll finish this thing up and get it all done. Finish building it, painting it, mounts for all the leads and getting all that stuff done. So for now, that's gonna be it for this video. Let me guys know what you'd like me to focus on in part 2. Is there anything you wanna see more of, less of, etc.? Just let me know in the comments below. But for now, thanks for watching. Thanks for subscribing. I'll see you guys next time. Goodbye.